In the Testeract Automated Test Framework, or ATF, one of the key pieces is the test sequencer. Although you can use other test sequencers like OpenTap, the one that is the most common and currently offers the most benefit is NI Test Stand. When working with the Testeract ATF and Test Stand, you first ensure your instruments are in the hardware abstraction layer, or HAL. You then create a series of test stand sequence files called TMLs, TALs, and the client file. The TMLs, or test module libraries, communicate with the instruments via the HAL using driver calls. The TALs, or test abstraction layers, define the parameters for the TMLs based on the required tests. The client files bring everything together and define the UI. Once you complete the client.seq file, you can use it inside of Task, Tesseract's single user experience. Task stands for Testeract Automated Solutions Controller and puts everything in the same application space, providing maximum development and debugging flexibility. The framework helps you create a standardized structure for your test system. To better understand how it works, let's check out an example. The framework can be used for whatever type of device you are trying to test, but to make it simple, we will create the software to test a flashlight. The basic procedure for testing a flashlight will be to turn it on and measure the brightness. To turn on the flashlight, we will need a power supply, and to measure the brightness, we will need a photometer. We have already put those two instruments in the HAL, or hardware abstraction layer. One of the most powerful things about Task is that it interacts directly with the HAL. It puts all of our applications in a single application space and is able to handle all of the instrument sessions to make sure that things all work correctly. As you open it up, it will start out in operator mode. This is what the operator will see when running your test. For this demo, we already developed the test stand sequences, such as the TMLs for communicating with the instrument, the TALs for the different flashlights we may want to test, and the client file for the operator UI and to bring everything together. Let's choose the old-timey flashlight and run the test. Next, let's say we get a new flashlight and need to test that one also. In the UI, we choose the new flashlight and run the test again. When we click Stop, we'll see an automatically generated report with our results. In these results, we see that the old-timey flashlight only tested up to 4.5 volts, but the newer flashlight needed a test that went up to 5.5 volts. We were able to do that all through the same interface and with the same instruments. The operator only needed to know which flashlight to test. The system used a different test abstraction layer for the different flashlight, which used the same instruments but with different parameters. I noticed that my test failed, but I'm not sure why. To look deeper into it, let's open up Task as an administrator. As an administrator, I can see a lot more options in the form of modes. A mode is a specific configuration of software pieces and test sequences for a given test scenario. I have a mode for each instrument, which means I can click on any of the instruments and look at them individually. I also have the ability to log everything I do using the logger. Every step that we or the software does is logged here. This is extremely useful in debugging because you can know exactly what happened when you ran the test and easily find the problems when they occur. Let's go ahead and clear the logger. Along with logging functionality, you also have record and playback. Let's make a recording of a procedure we would like to do. We click the New button, then click the Record button. Then we click Start. We'll go over to the power supply and first specify which power supply we are using. I'm using a simulated power supply that I specified in the HAL called DCPS. I then turn it on. Next, I navigate to the output and go and change the voltage to 3.5. Next, I want to take a measurement on the photometer. I go to the photometer and choose the simulated one I configured in the HAL called photometer. Let's take a measurement. Next, I go back to the power supply and change the voltage to 4.5. Then I go back to record and playback and click Stop. All of the things we did are in there. I can click on each of them individually to see what happened. I can also edit them using the editor. I realized I forgot to take a measurement after changing the voltage the last time. In the editor, I can duplicate this step and do it again. I also realized I wanted to add one more test at 5.5 volts, so I can duplicate this step and change it to 5.5 here. I can then add one more photometer measurement as well. To save time, I can also highlight all of the steps and change the wait time. In this case, I will change it to 1 second so that you can see what is happening. Once I'm done editing, I can play it back. If I look at the logger, I can see that it executed the same steps as before, but added in the extra ones that I changed. I can also save this recording to use later, and I can even export it as a test stand sequence, which can save a ton of development time. Using Task in combination with the Testeract HAL and test stand gives very powerful options for designing and debugging your test systems. If you are interested in exploring how you can reduce test development time by 50%, visit Testeract.com.